Let's talk about operating systems. Now, the operating system plays a very important role in a computer system. The operating system serves as an interface between the applications that are running on the computer and the computer's hardware itself. Now, this is a misconception that I do run into occasionally. Many people think that the computer hardware itself, the box, the hard drive, the floppy drive, and all that, is somehow tied to a particular operating system. They'll say things like, well, this is a Windows PC, or this is a Mac PC, or this is a Linux PC. And that's actually not quite accurate because the computer hardware and the operating system are modular, meaning that I could take a given PC and take Windows off of it and install a different operating system on top of it. For instance, I could install Linux on top of a PC. I could install NetWare on top of that same PC hardware. Likewise, with a Macintosh, a lot of people think, well, Macintosh, yeah, those, you can't run any other operating system on Mac hardware. Well, that's not true either. You could take your Mac OS off of a Macintosh PC and install Linux on top of it, okay? So the hardware and the operating system are not necessarily tied together. They can be separated. Now, what are the tasks that the operating system fulfills? Let's take a look. The first job that the operating system does is it provides a platform for your applications. Your applications need a place to run. And you probably know this. If you've ever bought an application from the store, what's the first thing you check? You turn and look on the side of the box and say, okay, what does this run on? Does it require Windows XP? Does it require Windows 98? Does it run on Linux? Is it a Mac application? The applications themselves cannot run directly on the PC hardware. There has to be an operating system sitting in between to allow this to happen. If we were to depict this with a diagram, we could draw it like this. Right here, we have our PC hardware. This is the motherboard, the CPU, the memory, the hard drive, the floppy drive, the video board, all that stuff that makes up the PC hardware itself. On top of the PC, we install an operating system. We'll label that OS. The OS is installed and runs on top of the PC hardware. On top of the operating system, we install many different applications. And that leads us to the next operating system task, and that is moderating the hardware. And these two actually work hand in hand. Not only does the operating system provide a platform where the application itself can run, but it also provides easy means for the applications to access the hardware in the PC. Essentially what we have in the operating system are special routines that are written into the operating system itself that allow the programmer who's writing an application to access a certain piece of hardware in the PC without having to do a lot of work. For instance, let's say that we have an application that we're writing and we want to be able to send a print job through an LPT port on the PC system itself. Without an operating system, with the application would have to write exact instructions for accessing the LPT port on the PC hardware itself. Well, for the most part, when we're dealing with operating systems, we don't have to worry about that because the person who wrote the operating system took care of that for us. We can say simply, send this print job to LPT1, and then the operating system takes care of all the nitty-gritty dirty work that's actually required to format the job and get it out to the LPT port itself. So we provide an application platform and we moderate the hardware for the applications as well. The next job that the operating system performs is to provide security. Back in the old days, this really wasn't a job that operating systems were concerned with. But today, this is a huge job. Back in the old MS-DOS days, anybody and their dog could come up and use your computer. There was no login, everything just worked. Well, today that's not the case. Any operating system you're going to use, such as Windows XP, Mac OS, Linux, is going to require you to provide some kind of credentials to use the PC. For example, you might have to log in with a username and a password. The operating system will check its database of valid users and their passwords and decide, based on that information, whether or not you can use that computer or not. Very powerful, something that today is very, very, very important. Another task that the operating system performs is that it manages our file system. Now, the file system encompasses all the different storage devices that are installed on the computer. It kind of relates back up to this point up here where we talk about moderating hardware. Well, in this case, we're specifically talking about working with specific pieces of hardware, such as the hard disk drive, the floppy disk drive, a CD or DVD drive, or a flash ROM drive. The operating system is responsible for organizing and storing the data that you're working on one of these storage devices, whether it's a hard disk or the floppy disk or whatever. So as you can see, the operating system plays a really important role in the computer system. Without it, a lot of the things that we take for granted wouldn't be possible when we're working with the computer. For instance, being able to log in, being able to open, write to, and save a file, being able to send a print job. All of this would be very, very difficult without an operating system. Now, the operating system itself is composed of different parts. Let's take a look at them. The first part or component of the operating system is what we call the kernel. The kernel is just that. It's the core of the operating system. It's what's loaded into memory when the system boots up, and it's what does most of the critical operating system jobs that we just talked about. It's responsible for managing the file system. It's responsible for managing security, for working with the hardware, and providing a platform for applications to run on. Now, the funny thing is the kernel here is something that you really don't interact with very much. The kernel is running behind the scenes, and it is working hard doing the bulk of the work. What you actually end up working with most of the time are utilities. Utilities are another component of a typical operating system. The utilities are the parts that you actually work with on a day-to-day basis. For example, if you're using a Windows PC and you double-click on My Computer and you browse to your hard drive and double-click on a file to open it, you're using a utility. You're not actually using the kernel, but you're using a utility that's part of the operating system that's interacting with the kernel to do a particular job. Most operating systems come with lots and lots of utilities. Back in the old days, such as working with MS-DOS, there weren't that many utilities to work with. They're very basic. They only did a very limited range of functions. Today, operating systems are huge, and the big chunk of the hugeness comes from this right here, the utilities that we pack in around the kernel. We could draw that like this. We have our kernel, and then all around the kernel we have lots and lots and lots of different utilities. An operating system also has to have one other key thing, and it's one of those things we just assume is there, but we really shouldn't because it's a key component, and that is an interface of some sort. Now, the interface is what allows you and me, as the organic user, to interact in some way with the kernel and the utilities. There's two different types. One is the command line. You remember DOS? DOS had a command line interface. We had a little prompt at the bottom of a black screen, and if we wanted to run a program or run a utility, we would type the command in at the command line and hit enter, and something would happen. With the advent of Windows, the command line kind of went away for a while. But recently, the command line is getting more and more popular again. And it's not necessarily with Windows. It's with a newer operating system called Linux. Linux makes heavy use of a command line interface. Command line interfaces are really powerful. The problem with them, however, and the reason why command lines kind of disappeared for a while, is because they can be very difficult for end users to use. That's why we have another type of interface, and that's called the graphical user interface. We'll call it GUI, which is affectionately known as a GUI in the industry. A lot of people get uptight about saying the term GUI, but that's what it's called. With a GUI, we take, and instead of using a command line, we represent things graphically on the screen. If you've used Windows and you've seen icons on your desktop and a start button that you click on with a mouse, you've used a graphical user interface. As I said before, the command line kind of went out of style for a long time, and it's starting to come back with the use of Linux. Now, Linux itself also includes a graphical user interface that isn't quite as advanced as perhaps the graphical user interface used by Windows or the Mac OS. Now, there's been a lot of debate over the years as to which interface is the best, whether it's the command line interface or the graphical user interface. And you know what my experience has been is they're both fantastic for different purposes. Sometimes you need the power and flexibility that's offered by a command line interface. However, when you're doing just day-to-day work, it sure is nice just to be able to double-click on something and have it work. Remember that the kernel itself is the part that provides the main operating system. It's the one that moderates our hardware and allows us to work with applications. We use an interface to use utilities and run applications that run on the kernel itself.